Hi guys, hope you are doing well as you work through e-learning. I miss seeing you in class. This is definitely not the same and definitely not how I expected the year to be going at this point, but we'll make it through. I've been really impressed with the amount of work and quality of work that you guys have turned in. Please keep up that great work. But I think we're probably ready to start working on something new, which is really exciting that we're going to start that today. It'll be a little bit of a transition and an adjustment, but I think we can really make this work, okay? So I'm going to be posting videos like this for our notes as we continue on until whenever we're able to go back to school. You can pause the video, you can rewind at any point, whatever it is that you need as you're going through the notes. You should have the notes either pulled up in Notability, or maybe you're deciding to take notes on paper, something as you go through to take notes that you can then use as you work through extra practice problems this week and beyond. Okay. Today we are going to be starting chapter 8, and section 8.1 is all about solving algebraic equations. I'm really going to be chunking this and breaking it down into smaller bits so that you're not so overwhelmed with information at once, and then we can kind of take it step by step. So really today we're only going to be focusing on when we have equations that we need to either add or subtract to figure out the value of our variable, okay? And these are called inverse operations. You can see that word up at the top. Inverse just means that they're opposite, just like adding and subtracting are opposite. Okay, so you're going to hear that word a lot as we go through today, so just know that inverse is another word for opposite as we go. Okay, so our first thing that we're going to be looking at is how to solve algebraic equations involving addition and subtraction. We have this picture here with our scale. And when we think about algebraic equations, thinking about a scale is a really, really great picture to help us as we're kind of going through the steps. When we have equations, when they're equal, they need to be balanced just like a scale. So whatever we have on one side of our scale needs to equal what's on the other side. Okay, so if we take a look at this picture and in our green little key off to the side, it tells us that one little box represents one counter, and then our longer box represents x counters, or that unknown variable. Okay, so we need to have our left equaling our right. That's what always works with our scale. So as we look at number 1, the first thing I want us to do is figure out or write an equation that represents our picture above. So let's figure out what we have on our left side. We know that we have an unknown number of counters of x, plus we also have 6 counters, or 6 here. Okay, and that is equal then to the right side of our scale, which is 9 counters. So our x plus 6 equals 9. That's our equation that we're going to be starting with to be able to solve. Okay? Now that we've identified our equation, we can take a look at now the steps into solving and figuring out what that value of x is. Now, some of you might be able to do this in your head right away, but as you work through these problems, and my expectation for you as you go through, and what you're going to see here as a model, is what you should be doing as far as what kind of work needs to be shown in order to earn full credit. It's going to be very helpful for me. The more work that you show, it helps me to have a better understanding where you're at and where maybe I need to help you out a little bit more. So please make sure that you are showing your work as you go through, and you'll see exactly what that expectation is as you watch me write my work for some of these problems, okay? All right, so with number 2, when we're solving the equation for the value of x, our first picture is the same picture we had above. It was x plus 6 equals 9. That's what we're starting with. Okay, but if we take a look at our second picture now, there's something that happened. There's some difference from our first picture to our second picture. We want to know what x is all by itself. So if I started with x plus 6 and now I'm just left with x on the left side, my first operation that I see is that I'm adding 6 to x. Okay, but to undo that, or to get x by itself, I need to do the inverse or the opposite operation of adding 6, which would be to subtract 6 from both sides. Okay, opposite operation, that inverse, I'm going to subtract 6. These cancel out, so now I'm left with just x, but on the left side, Now I have 9 minus 6. I need to take 9 minus 6. Okay, so as we transition now from the second picture to the third picture, I still have my x on the left side, and if I figure out what 9 minus 6 is, I'm left with 3 for 3 counters. 3 counters right here. This is our equal, x equals 3 counters. Okay, so we have an answer here, but what I want you to think about down here in the blue box is how can you check your work for this problem? All algebraic equations, you guys are going to be able to check your work as you go to really see if you have the correct answer. There's really no reason as to why we might not get 100% on something, because you do have the ability to check every single answer and correct it if needed. Okay? So to be able to check our answer, we want to think back, what was the original equation that we started with? We had x plus 6 equals 9. Okay, and so to check it, we found that x could possibly equal 3. So what I want to do is I want to substitute 3 in for x into my original equation and solve. If I take 3 plus 6, I get 9 equals 9. They're equal, therefore x equals 3 is my correct answer. Okay, so this is the exact process of how to check your work. And you will be expected to do this on some of the problems with the extra practice that's posted for your assignment. So please make sure that you're doing this. Okay. One last thing I want to point out on this page is just this other blue box over here, this remember. Again, thinking about anytime you're solving these algebraic equations, whatever you're doing to one side, you need to do it to the other side of the equal sign to keep it balanced, just like a scale. And through the pictures that we showed with the example on the left, keep it balanced. Something to remember. Okay, let's move on to the next page. If we take a look here, we're still looking at solving algebraic equations. However, now some of the problems might involve fractions or decimals. Okay, so I'm going to walk you through what to do here with those fractions and decimals. Honestly, it's going to be the same steps as we did in the previous example. You just have some different types of numbers that you're working with. Okay, so let's take a look at example 1. Solve the equation x plus 1/10 equals 3/10. Write your answer in simplest form. That's something to remember. Anytime you're working with your fractions and the answers, you need to make sure that you're writing your answer in its simplest form, lowest terms. Okay, so I'm going to start just by rewriting my equation here. X plus 1/10 equals 3/10. All right, and I first want to identify what operation it is that I'm starting with my variable. I want to get x all by itself. So right now I have x plus 1/10. X plus 1/10. So to get x all by itself, I need to do the inverse or the opposite operation of adding 1/10, which would be to subtract 1/10. When I subtract 1/10 from the left side, I also need to do that to the right side to get x all by itself. Okay, I'm left with x equals 3/10 minus 1/10 equals 2/10. But now I need to check if my fraction is in its simplest form. 2/10. Do they have a common factor that I could divide 2 and 10 both by? And the answer is yes, they do have a common factor, which I could divide both of these by 2. Okay, so 2 divided by 2 is 1, 10 divided by 2 is 5. So I have a potential answer as x equals 1/5. But I can check to really make sure that I have the correct answer by substituting in my answer into the original equation. So I'm going to show you that check part over here. Okay, I'm starting with x plus 1/10 equals 3/10. When I'm checking my answer with fractions, I want to use the unsimplified version of my answer, because I want to work with the fraction that has a common denominator already to make it one step easier in checking my work. Okay, so instead of using the 1/5, I'm going to actually use the 2/10. They're equivalent, they have the same value, but because my other fractions have a denominator of 10, it's going to make it a little bit easier to quickly check if if the answer is correct. Okay, so I'm going to take my 2/10 in for x plus my 1/10 equals 3/10. I'm going to check. 2 plus 1 is 3. My denominator is 10. That's equal to 3/10. They're correct. So this final simplified answer of 1/5, actually, I'll make that another color. There's my correct answer. 1/5 would be my correct answer here for x. Okay, last example that we are going to look at here is now working with decimals. Again, the steps are the same. The only difference is that you have decimals rather than whole numbers to work with. Okay, so I have x plus 3.5 equals 9.8. My first step, I want to get x all by itself. I want to isolate my variable. So I'm going to identify what operation do I have right now with x. I have x plus 3.5. So to get x all by itself, I need to subtract 3.5 from both sides. My inverse operation of adding is to subtract. These cancel out. I'm left with just x equals, and then you can use a calculator here to help you solve. When I subtract 9.8 minus 3.5, I should get x equals 6.3. But I want to know then, do I really have the correct answer? Okay, so to check my work, what I'm going to do, I'm going to start with my original equation. I have x plus 3.5 equals 9.8. I'm going to substitute in 6.3 for x. So I have 6.3 plus 3.5 equals 9.8. When I add 6.3 and 3.5, I get 9.8 equals 9.8. That's a check. Therefore, I have the correct answer here with 6.3. Okay? All right, as we move on to the final page, these are just extra practice problems for you to try out on your own and check. I am going to do 9, 11, and 19, and then you can try the other 3 out and check your work at the end. But I'm going to go through and model these 3 just to help you along, okay? So let's take a look here at number 9. So we have f plus 5 equals 14. My first step is to figure out what operation is already happening with my variable so that I can get my variable by itself. So right now we have f plus 5. Okay, so if right now I'm adding 5, but I just want f by itself, I need to do the opposite of what is adding 5, which would be to subtract 5. I need to do the inverse opposite operation. Okay, and if I do it to the left side of my equation, that means I also need to do it to the right side of my equation to get f all by itself. So on the left side, I'm left with f. On the right side now, I need to subtract 14 minus 5. When I subtract 14 minus 5, I get 9. My final step then would be to check to make sure I have the correct answer. I'm starting with my original equation, f plus 5 equals 14. I'm going to substitute in 9 for f and solve. 9 plus 5 is 14, and that does equal 14. So I have the correct answer here of f equals 9. Okay, moving on to the next one. W minus 6 equals 10. So first step again, identify what operation is going on right now with our variable that we're going to have to undo to get the variable by itself. So right now we have W minus 6. My operation is subtracting. So the opposite of subtracting would be to add. So I need to add 6 to both sides to get W by itself. These cancel out. I'm left with W on the left. And on the right side now I need to add 10 plus 6. When I add 10 plus 6, I get 16. And now I can check to see if I truly have the correct answer. W minus 6 equals 10. I'm going to substitute in 16 for W and solve. 16 minus 6 is 10, which equals 10. Those match, therefore W is the correct answer. Okay? And then the last one that we're going to look at together here is this fraction one down below. Okay, again, same step follows. We're isolating our variable by itself. We want to get k by itself to figure out what its value is. So right now I have k plus 1/8. That's my operation. It's addition right now. So to undo that, what I need to do is subtract 1/8 from both sides. Okay, these cancel out. I'm left with k. 7/8 minus 1/8 is 6/8. Now we need to check with fractions. We always have to check if it's in its simplified form. So 6/8, can we divide 6 and 8 by something that would give us our fraction in our lowest terms? Yes, we can divide both of these by 2 to simplify. When we divide by 2, we get 3/4. So that's a potential answer here for number 19. But to check to see if we actually have the answer, let's go back through and we're going to substitute in our original answer of 6/8 into our equation. Okay, so if I have 6/8 plus 1/8 to get 7/8, I check 6/8 plus 1/8 equals 7/8 equals 7/8. There we go. So 3/4, our simplified answer is correct. And I'll zoom out. Okay. At this point, you can try out the other 3 on your own. I will post the answers. You can pause the video, try it out for yourself, and then check your answers when you are done. Hopefully this video helped with our notes. I'd love some feedback if you want to let me know if this was a helpful way to take notes, or we can try to figure out some other ways, whatever's going to be best for you. Again, please reach out to me if you have questions, or join the Zoom sessions that I'll have going on this week as extra help, or just to check in and say hi. I'd really appreciate it. Okay, you guys are going to do great.